All right. So, hello and welcome to this uh, next lecture in the ongoing series of lectures on PDFX. Today, in this lecture, we are going to discuss on a very specific and perhaps one of the most important topics, that is the workflow. How to export PDFX files from both from different native design applications, be it design applications, non-design applications, whatever it is. uh, in this lecture, this is not going to be a one part lecture. This is maybe this may get even more than two parts. So what I will try to do, the agenda for this particular lecture is that first I will give you some idea about PDFX. Although in the earlier lectures, in some of the earlier lectures, you've already understood what PDFX is, but in this particular series, what we are going to do is we are going to focus on the GWG specifications, that is the Get Workgroup specifications, specifically version 1, I mean 1 version 4, which is based on X1A, and the 2015 version, which is based on X4. So these are the most popular and the most widely used specifications from GWG. So those things we'll also see what are the origin stories of PDFX, and some of the different flavors of PDFX that exist, why they exist, what is the reason behind so many types of PDFXs, I mean so many standards within PDFX. So all these concepts we'll be studying, and they definitely will also be talking a little bit about the different existing workflows that already exist in today's PDFX workflows or PDF generation workflows. So those we will be studying, and some idea I will also try to provide through some demonstration on how to properly create that PDFX, making it compliant with a specific standard or specification. So when I'm saying standard or specification, at least in this sense, it should be taken analogous to each other, but I'll also explain. I mean, the first slide is actually the difference between standard and specification. So that is one thing. And finally, when all this thing is done, then we will be seeing one very important topic, that is the specification itself, that is the 2015 GWG specification for production of PDFX. Those specification file also I'll be showing you, and there you will get a very good idea that what is allowed and what is not allowed. So I mean, in certain cases, in certain parameters, what type of workflow, I mean what type of color spaces are allowed within the PDFX file. So there is a list of that. So maybe what is the line width, what is the X height, all this, what is the image resolution, overprinting, different types of overprinting, all these things, specifications have been laid down in those documents. And the pre-flight profiles that we will be using for pre-flighting some files contains those specifications only. Okay, so once we get some idea about that, we'll also be able to understand the Get Output Suite 5.0. So what is the science, or what is the principle behind it? How does it really test our workflow? Okay, so why those right signs appear, why those X signs appear? So we'll try to understand those also, and from that we can get a fair bit of idea that where we need to work within our workflow to rectify if some of the patches are not getting rendered properly, and we fear getting, I mean, getting this X symbols in that output suite. So this is the entire layout of the lecture. So I'll try to complete this within maybe 3 parts, hopefully. So having said this, let us proceed. But yes, obviously this entire lecture series that I'll be developing, this is based on the different webinars that have been already produced by GWG, and that is on their website. This website specifically for creation of this particular PPT and this particular lecture series, I have used the webinar that is termed, I mean, that is title is PDF creation and workflow strategies, and all the recordings, all the original slides you will be finding uh, in these links that I have shared. Okay, so I encourage all of you to please visit those websites to please download those slides and see and watch the recordings as well of the past webinars, as well as there are various upcoming webinars that is hosted on their site. So please do watch those videos with those webinars. They're very informational videos, and they are very practical oriented. I mean, it's not just simply that that will talk really about the theoretical aspect, but it is more of practically oriented webinars. Okay, so having said this, let us now proceed with the with our presentation, right? So now see, when we talk about the two terms, that is standard and specification. So what is the meaning of this? So now we know that we are quite familiar with ISO standards, right? Especially in the graphic arts, I have talked a lot about the different standards, and you must have I must have confused you a lot, because all these 2846, 12647, 10128, 15339, 13655, all these things I have talked about, 12464. So all these things we have talked about, and what we have learned from those things, or learned from those discussions, is that standard, when you are using this term standard, it means it is a level of excellence, right? Standard entails that it is a level of excellence. It may be of a product, it may be of a service, it may be of a process. So in our case, when we, for example, when we are talking about our standard, our very universal standard, that is 12647, what is the what is at the core of that standard? If I ask you what is at the core of that 12647 standard, what will be your answer? Obviously, see, 12647 is saying, if you take a look at the standard, it is saying that if these and these conditions are met, if you do these and these methods and ensure process control in this and this method, your printing will be good, of that particular level, of that particular quality, right? So it is helping us to ensure a certain level of achievement, a level of excellence. So this is what a standard is. I mean, the even for processes, other processes, like your very popular 9001 or 14000, what are all the standards talking about really? 9001 is a standard which says that the processes, business processes and operations processes and documentation, these has been maintained properly or not, whether all the documentation is there, all the procedures have been followed or not, as per the guidelines given in the 9001 standard. If there is, then an auditor will visit the business, and they will audit all the processes and all the documentation, and if satisfied and if all the conditions are met as per the standard, the company will get the certification that yes, this company is ISO 9001 certified. That means it has achieved a level of quality, right? So that is what a standard is. But on the other hand, specification is a little bit different, right? uh, you can think of specification like uh, so let us say that, let us consider 12647 only, in our case only. What is the output of 12647? You are getting a specific quality of print, right? You are getting a specific, a print having a certain quality or certain level of excellence, right? But in order to get those type of quality, what you need to do? So the idea is over there that when we are talking about specification, we mean certain parameters, certain values of those parameters to be specific, which should be uh, followed. Maybe not only parameters, values of specific parameters, but certain processes which need to be followed in order to achieve that standard. So that is what a specification, that is the that is the meaning of specification, and that is what the difference in this two terms, that is the standard and specification, is all about. Okay, now in our context, what we will be seeing is that these two terms will be using almost interchangeably when it comes to PDF. I'll explain why. We will be using these two terms, and why we can interchange, at least in this context we will be doing that, right? Now, so slowly and steadily we are now starting our discussion on the PDF file format. Okay, so as you know, we are almost, PDF is now the de facto file format for exchange of any data, be it your through electronic media or be it for the purposes of reproduction through print. Now the question is, why is PDF, why has PDF become so successful as a format, as a file format for exchange of data? First of all, it's universal, right? Universal meaning that it does not really have any dependence on any system or on any software or anything for that matter. Nowadays, even if you don't have a Adobe reader or any other software reader for that matter, PDF reader for that matter, you can very easily open the PDF files on your browser also. So that it's completely universal, right? It is self-sufficient. This is quite important. You remember, I don't know if you have seen that lecture, but in one of the lectures where we discussed about the different transparency groups and the transparency blend spaces and the blending modes and all these things, I discussed about, or I demonstrated the various objects that are present within the PDF document. If you remember that car with the magenta and Rhodamine background that we did, so in if you take a look at the list of objects that is present in the PDF just by viewing, clicking on the object viewer, you will notice that all the objects are stacked one upon the other. I mean, there are, maybe there is a blending group, or maybe there is even any specific group between two objects. Maybe it may or may not have a transparency, but what does this mean ultimately? It means that PDF file contains everything within itself, and that includes your fonts, that includes your images, that includes your embedded ICC profiles, and all these things you'll be able to notice. Next, another very important aspect or the feature of the PDF file format is that it is compatible. That meaning that it is compatible with a lot of other vendors products, be it your different browsers, be it your different systems, be it your different other viewers from companies. So that makes it a very easy to use and easy to build software around this particular format. And as I already told you, it is vendor neutral, right? And it is very much compact, because when you create, last time, I mean, even in one of the lectures where I had shown you the different versions of creating an, when we exported the same InDesign file into different versions of PDFX format, there we also noticed that how in PDFX1 format and the PDFX4 format, the data, I mean the file size changed, but ultimately what we noticed is that the file size was reduced in comparison to the native file in which we were editing that particular file with, right? And again, it is very much well behaved. The PDF format is extremely well behaved in nature. Now, in the late 90s, around the if I remember it, around 1999 or 2000, this particular period, originally PDF was created by Adobe, but later on during the late 90s and early 2000, there was a time when they decided to share the intellectual property, that is create a ISO standard based out of it. So they handed over the entire PDF format along with the intellectual properties and everything to the ISO, that is the International Standards Organization, and therefore thereafter the PDF format came to be known as the PDF 32,000. I mean ISO 32,000. So now PDF is no longer, PDF does not belong to Adobe anymore, but it is an ISO standard. The number of the ISO standard is ISO 32,000. Okay, and as I told you that the 32,000 is the primary standard, and two parts, it came into two parts. The first part was published in July 2008 and the second part in 2020, December 2020. The first part contained the various aspects of PDF file structure and all this. In the second part, it was clarified, this was needed because how to develop various other functionalities and all those specifications that was published in December 2020 as the second part of the ISO 32000 standard. Now, this is a very interesting picture. This is that Russian doll, that Matroskaya dolls, that where one doll, the smaller doll, fits into inside of the bigger doll. So ultimately, when you take out all the dolls outside of the containers, each other, it will appear that these many dolls are there. But it is possible for you to put this small doll inside of this, and you continue doing this. So the reason, this is the background of this picture. Now the reason I'm showing you this picture, again, this picture has been shown by in one of those webinars, and from that only I took the inspiration of explaining in this way. See, the concept here is PDF has got standard within standard. The PDF standard has got a standard within standard. I'll explain why. See, the PDF is the primary standard, that is, it's a file format and its specification, how to create that PDF file, what is allowed, what is not allowed, everything within the PDF file, that is now part of the ISO standard. And there has been multiple revisions and upgradations of those particular standards, the PDF standard. So right now, in the, I think in 2020, PDF 2.0 was supposed to come. So there are various different versions of the PDF standard. Now the reason I am showing you this picture is all these different formats, that is, be it PDF X, PDF A, PDF VT, all these formats, they are uh, what can you say, they are a subset of the original PDF standard. So for example, let me explain why I am saying this. So a PDF is a universal format, as you all know. Now, almost anything you can put within a PDF file. You can put a video, you can put a hyperlink, you can put audio file, any interactive media, you can put almost anything within a PDF file. But the question is, can you put those content, like the contents of the elements that I just mentioned, can you use those particular contents in a particular PDF X file, right? So you already know what PDFX is, but still let me just give you a small explanation of what PDFX is. PDFX is the file format, which is ultimately, it's also a standard, but it's a file format which is, again, all these specifications, subdomains or subsets of this PDF, they're all PDF files itself, but this is very specific type of a PDF file. PDFX is meant for creating files that are intended to be printed, right? Hard copies. PDF A is meant for those files which are meant to be archived or stored for digital reproduction or digital transmission. PDF VT is for variable data printing. Okay, so these are all various subsets of the original PDF. Now, what why was it essential to create all these subsets, to create all these uh, you know a standard within standard concept, right? See, the elements that I told you just now, that is that video or that interactive media, maybe some flash content, maybe some audio file, whatever you can put within a PDF file. The question is, can you put those same contents in a PDF X file? Right? The answer is no. Why? Because you cannot print it. You can put a video in your PDF file, but you cannot print it, because you can only use some static objects, static elements in your PDFX files for it to get reproduced correctly in your through your printer. So this is exactly the reason. But you can use those interactive media maybe in a PDF A file, right? So this is exactly the reason why it was necessary to create these subsets of the standard from the original PDF file format of the PDF standard. PDF is a all encompassing standard, right? You can put anything, almost everything within that PDF file. But you can't do the same for the PDF files that are meant for printing. That is why it was essential to create some subsets of the original standard, that is PDFX, A, VT, E, U, all these subsets of the original standard, that is the PDF, that was needed to be created. So in that context, if you consider this to be the biggest doll to be PDF, then this may be PDFX. And what are the rest of the dolls? That is something that we need to discuss later on, because You might ask, so okay, so if this is PDF, then this is PDFX, this is PDF-A, this is PDF-VT. No, that is not. If this is PDF, if the largest doll here represents the PDF standard, so one subset of that standard, and what is allowed and what is not, so that is a constrained version of the standard, that is PDFX. So what are the rest of the remaining of the dolls that will come to? Will not be using all the dolls maybe, so I should have given only 3 dolls. That would have explained the concept much more coherently, but nonetheless the concept is the same. That is, PDFX is a standard within the standard. So if PDFX is the standard ISO 32000, then PDFX has got its own standard, that is ISO 15930. You already know about these standards. So, and that is not a single standard. You will see that there is a series of standards, a family of standards, so many versions of the standard. Okay, so because when we have got these various versions of PDF also, what is the purpose of creating more and more versions? You can say that larger version numbers means betterment of that file format, or betterment of that standard. It is not always correct, but yes, to some extent it is correct that maybe there are certain elements. For example, PDF 1.3, very very useful example for us. PDF 1.3 did not allow transparency. PDF 1.3 did not allow for live transparency, right? So any transparency you might have in your file, if you wanted to print it through the process of creating a PDF, everything had to be flattened. That we have already explained in great detail. But PDF, from PDF 1.4, 1.5, all these things, all these versions onwards, live transparency started to be allowed within a PDF file. So these are the advantages. I mean, the creation of the different versions, the purpose of creation of different versions of a particular file is that various other features that might not have been present in the earlier file format now is not available. Especially this is quite important for PDF2. We'll discuss that also in a separate lecture. Why PDF2 is a kind of a big deal. That one example I've already given you. So consider this: you've got a PDFX file created, right? Now, if you want to take a look at the output intent that is associated with that file, you will find only one output intent. This is the example that I always give. So, for example, you are going to print a book or a magazine maybe. So where the magazine cover is to be printed on glossy paper, and the inner pages are going to be printed on uncoated paper. So naturally you would need to impose the entire thing or take a look at the entire thing, right? Now, at this present moment, it is not possible for you to associate. So naturally the output intent for your cover page will be different from the output intent of your inner pages. Obviously this is quite true. Now it is not possible to do with the PDF existing PDF standard, because you need to associate only a single output in your only a single output intent is can be associated with the entire file. But with PDF 2.0 or the PDF X6 version onwards, it will be possible for you to associate different output intents for different pages of the document, solving that problem. So naturally, the purpose of creating different versions of higher versions of the product is naturally to ensure that there may be certain things which were not present, those functionalities, those advantages were not present in the earlier file formats. Now it is present. So that is the entire purpose. So hopefully this concept of standard within standard is now clear to you. Okay, so now we start with the story of the origin story of the PDF. So before coming to this slide, I think I had another. Yes, I'll try to show you this slide, then I'll explain what this slide is. So see, in the late 90s and all, there was a growing demand. I mean, even before that, there was a growing demand from various printers and publishers that what maybe some specifications be provided to them, which would say that these things are allowed within a PDF file that is meant for printing purposes. Okay, question is why? Maybe this is a very important thing. Maybe the designer is providing the PDF file, and that PDF file has got an embedded ICC profile. I mean ICC based RGB profile. Maybe the color space itself is in RGB. The blending mode, I mean the transparency blending space is in RGB. So all these are the causes of problem. This will ultimately create a lot of trouble for the printer and the prepress department of that printing organization. So there was a growing demand of creating some specifications uh, which would say what is and what is not allowed in a PDFX file. PDFX meaning a file format which is again a subset of the PDF, but it is meant exclusively for the purposes of printing. So that is what the the story behind this PDFX is. Now, in the United States at that time, there used to be this organization, Digital Distribution of Advertising for Publishing. This organization received from their members a lot of suggestions, lot of feedbacks that there should be some specifications, some standards relating to what is and what is not allowed, and even if it is allowed, what are the parameters that these things should be having, and then for the production of PDF files which are meant for printing. Till then, we did not have the PDFX file format. Now, the moment I also took up the PDF file as for maintaining it and for upgrading it for creating the ISO standard, ISO 32000 in 2001. From that point on, uh, the this particular PDFX, the concept of PDFX file formats came into being. This was actually developed among others by DDAP. The PDFX1 was the original PDFX file. So the concept here is quite interesting. You need to know what that X means. So in case of your PDF A, as I told you, that A stands for archiving. So what does, in our case, in graphic arts industry, what does this X mean? X stands for this picture that I wanted to explain. This is blind exchange. What does it mean? So X comes from this blind exchange, the X of the exchange. Okay. So on the left hand side, what we have got a designer maybe, right? And on the right hand side, we have got a printer. On the left hand side, he may be a designer, photographer, whatever. Ultimately, he's a designer. He's sending some artwork to be printed by the print shop owner. I mean, this is the print shop owner of the employee there. Now, this designer is sending a PDF file to the printer, right? Normally, this is how things have been for quite a long time now. They send PDF files. Now, he may unintentionally, he does not have a good idea about what is allowed in a PDF file if it is meant to be printed. It's not expected of him, right? We cannot expect him to know what an output intent is, what this rendering intent is, what this, various color spaces are, what is transparency, and how does it impact, whether it needs to be flattened or not. He does not need to know all that. He's the designer, he's a creative person, he's creating what his maybe his client is asking him to do, or maybe if he's a photographer, he's doing what he likes to do in terms of creating a photograph, editing a photograph, whatever. Ultimately, his intention is to get it printed. That is all he cares about, right? We cannot expect him to learn this. This can be allowed. This cannot be. No one can be, bothered to do all this, right? So the onus falls on the printer alone. And the reason why I'm saying this, why this is important to see, so when your designer gives you a file format which contains all these things which cannot ultimately be printed, and it will be getting converted into something else. So for example, if your designer has given you an RGB file and it needs to be converted into the output, I mean the CMYK color space using the output intent, and the colors are bound to change. That is how it works. But the creator does not know this. The designer does not know this. He was seeing a very vivid and gorgeous image on his computer screen, but ultimately after printing, he will say, "Oh, what have you printed? What have you done to my photograph? What have you done to my design?" So the printer will say that what I could do. You sent me a file which we could not print. See, he said he would have, this designer would respond, maybe you should have told me this earlier so that I could take a look at it, and if necessary, I could have edited the image. So this is an imaginary conversation that I'm trying to build to make my case over here. Okay, so normally this is it may be an imaginary conversation, but this is exactly the most likely conversation that is likely to happen between a designer and the printer. So the concept of blind exchange came from this problem itself. What does it mean? It means that no matter what the designer intends to do, or whatever elements he intends to do, if there is a process through which he can visualize, or he can maybe there is a file format which allows him to put all the elements in a manner which can actually be printed. In that way the designer can easily view what his file is going to look like after it is getting printed. So it's kind of a blind exchange. As soon as the creator is creating this particular file format which serves this specific purpose, that contains all the elements which can actually be printed, and it provides kind of a visual simulation of what the file will look like after it is getting printed. So he does not, if this happens, if there is a facility like this, if there is a file format which supports this, then the designer would not be facing this kind of a problem, nor will the printer be facing this kind of a problem. The designer would know exactly what you can give in that file, what is allowed, what is not allowed. He knows exactly, because the file format will not allow it. Even if he tries to put it, the file format will not allow it. Okay, he will not be able to export that file. If this kind of a file format exists which allows for this blind exchange meaning that there will be, I mean, we can in fact print this file without even any direct contact between the designer and the printer. If the designer puts his file in this format, or exports his, or generates this his PDF in this particular format, it will be printed exactly, and if everything goes right, it will be printed exactly how the designer envisaged it, right, by the printer. So there needs to be no kind of up and down loop of exchanges between the designer and the printer. So from herein came the concept of blind exchange, and ultimately the concept of PDFX file format, where the number of elements or the type of elements that you can put within a PDF file is specified. What type of objects you can use, I mean, what type of color spaces you can use, what is allowed, what is not allowed, all this is you can simply find out. So what is the advantage for the designer? He will know what is his limitations, right? For the purposes of creating a PDF file, there are no such limitations. But for the purposes of printing that PDF file, there are certain limitations, and he would know it automatically. If he's using a software where he's generating a native application, so where he's generating some PDFX files, exactly at the time of exporting that file, he would ultimately know what are the errors there, right? And what is the advantage for the printer? Advantage for the printer is that he would not face these type of problems, that maybe the designer has given him images in ICC based RGB, he has to convert it, and the colors will get changed, and transparencies would get flattened, and overprint may be allowed, maybe not allowed. So all these type of issues will not come to him. He'll simply, if it is complying with this particular, if the file that the designer has sent is complying with the PDFX standard, then he will simply be able to print, quite assured that this is exactly what the designer wanted me to do, or the designer envisaged this particular uh, file. So that is why, that is the importance of this concept of blind exchange. Okay, hopefully this idea is clear. So over the period of time, you see, there were many such file formats which were created. I mean, not file formats, I would say, the standards I would create. So please remember, PDFX is not a file format, right? PDFX is a standard. I mean, ultimately the file format is PDF only, right? But the difference between PDFX and PDF is, one, PDF is a file format, PDFX is a standard. Now you can say that, okay sir, you told PDF is also a standard ISO 32000. Yes, PDF is also a standard, but ultimately it is a, practically it is a file format. PDFX is not a file format. When you export a file from a native application, design application, to PDFX, then the file extension does not become PDFX. It still remains PDF. This you should be very much clear about. PDFX is only a specification, or you can say a standard, which allows certain things to be in the PDF file format, and does not allow the rest. Okay, so over time, with the creation of the PDFX1 standard by the DAP and others, it was soon taken up by the ISO, and it came to be known as the ISO 15930-1 2001. It was created in 2001 after Adobe provided PDF to ISO for it being ISO standard. So the PDFX1 was based on the PDF 1.3 file format. That did not allow transparency, so it allowed only blind exchange for CMYK and spot color. So what are the elements that could be present in that file in terms of colors? Only CMYK and some named colors, that is spot colors, can be allowed, right? No n colors, no your transparencies, none of that, live transparencies, none of that was allowed. RGB colors, these were not allowed, even ICC based colors were not allowed. Okay, so following that, then there was this PDFX2 that never got published actually. PDFX3 was published in 2002. This allowed for your CMYK spot, calibrated or the ICC managed RGB lab color spaces, right? Again, this was again based on 1.3. Okay. Then came a revision of the PDFX1 format, which came to be known as the PDFX1A of 2003. If you are trying to export your files using any native design applications like Illustrator or InDesign, you would see that normally the preset is set to the preset, the export, that export window. You will see that when you want to export that into a PDF, the preset option will say PDFX1 or X1, right? But the sorry, X1A, but the standard would say that to be 2003. X1 is 2003. Normally the preset will be set to X1A of 2001, but the standard would be set to X1A 2003. So this was the revision of the X1 of 2001, and was most importantly, this was based on PDF 1.4. So that meant that live transparencies were allowed. But at that time, I would explain later on that although live transparencies were allowed in PDF files from PDF 1.4 version, but ultimately this did not serve any, but I mean any good purpose. I will explain why later on. Then came PDF X2. This is no longer a a standard anymore. It was withdrawn in 2001. This allowed, this PDF X2 allowed for certain things, but this was again withdrawn. PDF X3, again based on PDF 1.4 only, this allowed this OPI, that is the your linked data, to be included within that PDF file. And then in 2008, this was quite important. This came to be known as the PDF X4, and the ISO name was ISO 15930-7 of 2008. This was perhaps the one of the most important and most still widely used PDFX standard today. So they allowed for color managed CFYK, gray, RGB, spot color data. They are all supported. PDF live transparencies are supported. OCGs, that is optional layers, optional content groups. These are all supported. All of these are supported, and it is based on your PDF 1.6 onward. Okay, and another standard also came out, that is X4P. This is used when the ICC profile in the output intent is externally supplied. So that is a very specific type. Now, there is another series of standard, that is the X5 standard. This was a minor corrections and improvement over the others, and it is again based on 1.6 only. There are three flavors within this X5 standard. So one is X5G. This is again an extension of the X4 that enables the use of external graphical content. So again, this is like the open prepress interface, or the linking of external graphics, which may not be present within the original file, may not be present within the PDF, but it is linked to some external file. That thumbnail is linked to some external file. So this was allowed actually. Okay, so even files which are present outside the PDF, maybe in some local drive or etc., so they can also be linked actually. Okay, so you can essentially work with low resolution images, reducing the computational requirement for processing those PDF files, or editing, not processing, I would say, editing those PDF files. But ultimately, during rendering, you need to enable the or place that original high resolution image into that PDF file just before rendering. Okay, so this was one type of that standard. Then came X5 PG. So this is again an extension of that X4P standard. X4P, remember, that is used for in cases where the ICC profile is externally supplied. So in that case, this was an extension of that format only. Now 5N is important because this basically uses or allows for the use of N color separation. So more than four, maybe for wide gamut, seven color separations when it is needed. This is basically for that particular purpose. Now next, the upcoming standard is of course PDFX6, which is based on the PDF 2.0 file format. So this is the overall idea about the different PDFX standards and PDF. Now we will be studying mainly about PDFX1A and PDFX4 standards, which are primarily used. So uh, your Ghent GWG specification 1V4, that is based on 1X X1A, okay, and 2015 this is based on X4 standard, right? So now let us go ahead and this is again one slide that is that I have taken from Adobe, and this essentially tells you what is and what is not allowed, and what is the PDF version based on which the standard is PDFX standard has been created. So if you just take a look at the X1A of 2001, that means this is the original standard, not the revised standard. So this is based on 1.3 Acrobat 4. This allows device CMYK and gray spot. ICC color management is allowed at ICC profile, and no light transparency, no layer support. OCG cannot be allowed. Page independence, yes. Blind exchange, obviously, all of them will have a specific blind exchange purposes, except for PDF 5, which has got a very specific reason for using. External print job control, that means job data, metadata can be, whether it can be allowed or not. Externally, it can be allowed. No annotations, no multiple page types, metadata. This is not allowed. Characterization, these are device dependent data, right? X3 again, these are the things that are allowed and not allowed in X3 format. X4, as you can see, device CMYK and gray spot, color managed CMYK, gray, RGB. All of this is allowed, and yes, live transparency is allowed. OCGs are allowed, and so forms and annotations, this is not allowed really. And this is again device independent. Characterization is device independent. Color spaces are allowed, right? And here this is PDF X5 and X6. In X6, I think, yeah, this is quite important. See, optional via dpart and page level output intent. This is something which I was talking about, referring to earlier, where you can set output intent in this PDF file page wise, right? This is based on ISO 32002. This is what the PDF 2.0 file is all about, right? So N color and support through X PDF X6N, black point compensation, all these things are allowed within the PDF X6 standard, which is based on the PDF 2.0 file format. All right. So next, we will be talking about that the rest remaining of the dolls. So till now, I think, let me just go back and show you. We talked about only this first doll and the second doll, perhaps, right? So from this point onward, I'll be speaking about this third doll. Okay, so what does this mean? So now you, from this point, you know already that this bigger doll is representing the PDF standard, and the smaller dolls are representing the various subsets within that PDF standard, which are essentially PDF files, but they are limited in what can and what cannot be added into those PDF files. Okay, so this is what this represents, once again, just to remind you of that. So yes, now see, GWG is the Ghent work group. It's a work group, professional work group, based out of Ghent, Belgium. So it was created in 2002 by some of the leading experts in academia, in industry, who felt that something needed to be done, some specifications needed to be developed for PDFX files. Now here the question comes: did all of these people suddenly think of creating these specifications? No, it was the demand of the industry. It was the demand of the industry. So what happened is, various people were asking to, I mean, again, as I said, that GWG is essentially a working group, but it consists of people coming from different industries, so OEM, and printers, and other manufacturers, and end users, and academics. So all this. So they were people in the industry, and everyone else were getting this kind of people were seeking advice from them, that can you develop some specification for the PDFX standard? I mean, what is allowed and what should be the value of this particular parameter? What should be the optimum value for the image resolution that I can put for maybe magazine printing, maybe newspaper printing, maybe sheetfed offset printing? What is the color spaces that can be allowed, and if I'm allowed to overprint same icon, same YK, and all of these people were seeking advice from different European countries to some people. So these people came together to become or to form Ghent work group. So their intention was they have created their intention was to create specifications on top of the PDFX, this blind exchange standard, and they have developed various tools for the print and publishing industry, and they have also created a lot of added a lot of members in their journey ahead. And the result is what it made easy for an increasing number of professions around the world to successfully create, process, and exchange graphic art files for numerous applications. So imagine when the person when some print media owner, print shop owner is asking for help in this particular context. Maybe they don't know that what are the things that is allowed in the PDFX files, or maybe they are not sure that their client has sent some PDFX files, and maybe they are facing certain problems. So these specifications that I am referring to, these specifications has helped the uh, industry at large to know what is allowed, to use those specifications to their advantage to create error-free PDF production workflows, and ultimately render them correctly. So this ultimately helped the print industry at large in various countries and even throughout the world, I would say, to create those error-free PDF production workflows, and ultimately resulted in proper rendering of those files that people were. Now the question is, we're thinking about. Now the question is, why is it necessary to create these types of specifications? So when I say specification, I want to be very clear about it that GWG does not call it standard by design. They call those specification because this is the reason why I talked about the difference between standard and specification. So let me just give you one. I'll come back to this, but let me just give you take a look at this particular slide. This is quite important. You see, PDF is the primary standard, that is the ISO standard 32000. Based on this, you have got the PDFX, that is for blind exchange, that is 15930. Now this 15930, that PDFX standard, is based out of PDF only. So it is you can say, that is why I'm saying it's a subset of that entire 32000 standard. So what is allowed and what is not, that is present in that ISO standard. And you have got various versions of those standards like X1A, X4, X6, and all those standards are there, right? So the question is now, what is the necessity for the Kentwa group to prepare specifications on top of this PDFX? Now, from the term on top of this, hopefully now it is clear what is the purpose of all those dolls. So if PDF, ISO 32000 is that biggest doll, the doll that fits within that biggest doll is 15930. The doll that fits within that doll is GWG specifications. So what does GWG specifications actually do? GWG creates specifications for different markets and for different processes. So for example, for newspaper ads, for magazine ads, same sheetfed CMYK, sheetfed offset spot high resolution pages, for digital, silk screen, wide format, office documents, packaging. So these are all various types of workflows. But ultimately, what is true? PDFX is the de facto standard for receiving files from by these companies or by these processes from their clients, right? But you say PDFX is a standard, I mean ISO standard, it's for global use. So yes, in PDFX standard it is written that what type of color space is allowed or what type of color space is supported by the let us say PDFX 4 standard, right? Whether transparency is allowed or not, that is written over there. It's very global in nature, right? When I say global, I use this term in both senses. That is, I am using this term global, that it is meant for being used. This PDFX standard is meant for being used across the globe by various nationalities, national printers with different nationalities, different markets, different workflows, different requirements, all this. So you cannot be very specific when ISO is creating PDFX standard, they cannot be very specific that okay, so the resolution in image resolution should not be lower than this. They cannot be so much specific because there are a lot of different types of job. Maybe someone is printing large format flex like hoardings on the which is to be put up on the roadsides, which you are meant to see from maybe 100, 150, 200 meters away. Some other printer is printing a magazine on a glossy paper. So, do you think that for both of them, the image resolution should be, or there should be a minimum image resolution below which they should not fall? No, that should not be the case, because when we are seeing the hoarding from this, I have explained in digital prepress also, uh, from a few hundred meters, then the resolution should not be that high. But when you are printing an image in a glossy art paper which is meant to be viewed from 25, 30 centimeters of distance, then naturally the image resolution has to be very high. So that is why PDFX, being an international standard, it cannot cater to, or it cannot be very specific about all these parameters, all these points, because it caters to a global audience of printers and workflow makers and all these things. But what GWG does is just to, but the problem with this thing is, with this situation is, uh, people sometimes face various difficulties. Maybe they don't know what should be the minimum line width. Maybe they don't know what should be the minimum bleed margin, or what color space is allowed and not. So or for a particular image, what should be the color space, what should be the resolution, all of this they don't sometimes know, because these information is not provided in pdfx is saying what is allowed and not allowed. I mean, what is supported and not supported. This is a binary situation. So this is a problem, right? In order to address this problem, GWG started to make these specifications for certain print conditions. So maybe someone is printing large format flex hoardings, which is to be put along the roadside. Maybe someone else is printing on glossy magazines. Maybe someone else is printing on wide format digital digital printers, right? So for all of them, their workflows are different. The requirements from their PDFX files are different. So instead of setting, case to case basis, one thing that printers can do, that okay, they can give I mean, create an SOP where it is written that okay, this for this particular someone who is printing maybe on a wide format, wide gamut digital printer, he has a certain SOP. Maybe someone is printing on a, I mean, people who are printing newspaper, so they have an SOP saying that for all our clients, these are the nature of the images, these are the parameters that should be maintained within the PDFX files that clients send to us. But this is a very non-standard approach of doing things. I mean, if every printer has got their own SOP, then it's very difficult for the creators also. So maybe you have maybe a newspaper company, right? They have got printing operations spread all throughout the country, maybe in 4 zones: northwest, southeast. So and a national brand is trying to get their ad out to be printed in all these regional newspapers. And maybe because the machine is different, the software is different in all these places, their workflow is different. So the same brand owner is expected to produce a PDFX file which is complying with 4 different SOPs for the same printer. It's a hectic process. I mean, it's a complete hassle. So in order to avoid this, or in order to mitigate or address this issue, what GWG did is quite interesting. They created specification based on markets, based on nationalities, and most importantly, even if you, I would say that these are not really the guiding parameters or guiding criteria for creating GWG specifications. But what they did is they did process oriented or printing condition oriented specifications for PDFX files. So this is one step on top of that PDFX standard. So this is that third doll that I was talking about. The first doll is the PDF file, second doll is the PDFX file standard, and the third doll is the GWG specification. So you have got a GWG specification for newspaper, another for magazine, another for sheet-fed CMYK, another for sheet-fed RGB CMYK, another for sheet-fed CMYK RGB spot, another for digital, another for packaging. All these specifications were created on top of the original PDFX standard. One was 1v4, which was based on X1A standard, and the other was 2015 standard, which was based on the X4 standard, right? So this is where the importance of this GWG specification actually come in, right? So this is where GWG comes in, and this is the various workflow. So I would not place all these dolls within this, because yes, you can say that if you really wanted to put all these dolls within the GWG, then all the size of the dolls should be same, because in the sense that uh, uh, they're trying to mean the same, their purpose is same. That is, this is maybe a newspaper specification on PDFX, this is a digital specification, this is the sheet fed specification. So all of this together goes into the GWG doll. So that is why this is a standard within a standard concept extended to encompass the GWG specification as well. Okay, so what are the primary difference between um, PDFX standard and the GWG specification? So on the right hand side, you will see this is the PDFX standard, and on the left hand side, so let me just write it down so that you can understand this well. Give me a moment, otherwise there might be some confusion. Let me just point it out. So this is the PDFX standard, right? Properties or features of PDFX standard, and this is the corresponding GWG specification, the same for the GWG specifications. Okay, so in terms of your GWG specifications, the rate at which it is being published or it is addressed to mitigate the problems of the industry, that is quite fast, right? Because they are very specific, they're very specific. So if a large number of organizations come to GWG, and this is how they address the problem, saying that okay, please develop a standard or specification for us on top of the PDFX standard for printing newspaper ads. So that is what they have done. The same for digital industry, for silk screen, and for the sheet fed, all these things. They're quite fast in delivering these specifications, right? The reason why they are not called standard is that because ISO is a standardizing body, GWG is not. GWG is a work group which is providing the specifications. If you use them, the likely chances of your PDFX file getting rendered properly increases manifold. That is why they are not standard, and therefore their specifications. Okay, in comparison to the GWG specification, PDFX standard is quite slow because it's a international. It is done by ISO. It is going to cater to the entire world. So the rate of publication of those standards is quite slow. GWG specification is more practical oriented because it is for a specific industry, for a specific workflow. But PDF standard, again, because of the same reason, that it being more theoretical, it has got a theoretical approach. What is allowed and what is not allowed. GWG is more user driven, again, for a specific user. That means for a specific industry. And PDFX is vendor driven, that is what is allowed and in that PDF file format and not. GWG is less accurate because it is catering to specific markets. So something, if you have you know used a newspaper ad GWG specification for a sheet fed, you are going to get wrong outputs, right? But PDFX is more accurate in that respect. GWG is diversified for specific markets, something which works with, I think, PDFX2. If I remember this correctly, PDFX2 is still being used in Switzerland. So these are specific, market. I mean, GWG had a specification on top of that, so that is still being used for in the Switzerland market. I mean, Switzerland printing industry. So they are very specific to regions. They are very specific to nations, and they're very specific to processes. Most importantly, GWG is specific, but PDFX standard is catering to a global audience. Okay, that is the primary difference. This now, hopefully this particular picture makes more sense now. So uh, at the bottom of everything, the guiding principle is PDF. Based on top of the PDF standard is your PDF X standard, which is providing that what are the features that are restricted for the purposes of graphic arts that is allowed within that PDF file. Based on top of this, based on the company specific or requirement specific, print condition specific, you are using the various GWG specifications, right? Two specifications, as I already told you, X1A and X4, right? X1 is based on PDF 1.3 and X4 is based, this is 1V4, uh, GW specification 1V4, which is based on X1A, which is again based on PDF 1.3, and GWG specification 2015 is based on PDF X4, which is again based on PDF 1.4. Okay, and then you can use and you can modify different GWS specifications based on your own company specific guidelines, your own requirements. So when you move from the PDF standard upward to PDFX to GWG to being company specific, you are having or you are facing more and more limitations. See, the number of limitations that are there in GWG specification is quite higher than in comparison to PDFX. Okay, so for example, PDFX does not specify what is the TAC, that is the total area coverage, or what is the image resolution, but GWG does. So it is more limited in that way. Limited in the sense it is not limited in features. I'm saying it is providing more limitations what is allowed and what is not in your file. But at the same time, it is also more reliable. Why is it more reliable? Because when you are using normal PDFX file and you're exporting your PDFs into files from layout applications or native design applications to PDFX files, you don't know what might go wrong because it's a binary situation. It's only saying what is allowed, right? But uh, when you are moving upward towards using Gantt specifications, company specific specifications based on Gantt specifications, so they are more reliable in nature. So you know for sure that I have said in my specification or in my pre-flight profile, I have set this specification in my pre-flight profile. So this will be if this element is present in the file from the client, there will be an error. I can send back the file to my client or do the necessary editing myself if the client allows me to do. So everything that you want and you have set that, okay, this is how I have this workflow, I want to follow this workflow, I have set up this particular workflow. This makes PDFX the GWG specifications more reliable in nature, right? Okay, hopefully this much is clear to all of you. So hopefully from here we can next move on to another discussion, that is what is, now let us specifically try to identify what is and what is not you can say specified both by PDFX as well as GWG specification. Now in this slide, as you see, I have pointed out a comparison between which uh, element, if used, will give an error in case you are only using PDFX standard for pre-flighting, and as compared to when you are using GWG specification for the purposes of pre-flighting. So let us say you have got an unintended spot color. Okay, so that means there is no output intent, anything, or any spot color that might not have any or not belong to a specific spot color library, all these type of things. So if you use that in PDFX, it will not be an error. X means not an error, okay, but that will be an error in case of your GWG, right? So right here means there will be an error. So whether it is in this case, error means whether it is detected or not, whether it is detected or kind of analyzed or by this GWG specification during pre-flighting using GWG specification. Okay, so why in case of PDFX it will not be an error? Because spot colors, as long as spot colors are there, it will be considered as a separate spot color plate, and PDFX will not throw up any error. Now, low resolution. If you're using an image with a low resolution image in PDFX, whether it is an error or not, see, it will not be the cause of any error during pre-flighting. But for GWG, yes, this will be checked, and it will be, if it is found to be below a certain resolution, it will be found to be an error. RGB images, this will be detected both by PDFX and GWG, right? Missing fonts, this will be detected both by PDFX and GWG. Missing font means whether there is no font embedded, or during that time there will be some error, and even if you are using those missing fonts, it will be substituted ultimately, and there will be an error that this font is missing. Hairlines, right? Hairlines will not be checked by your PDFX, but it will be checked by GWG. Tag, that I already told you, total area coverage of 4 color black elements, that will not be checked by PDFX pre-flighting profiles, it will be checked by GWG profile. Page size inconsistent, that will not be checked, that will be checked by GWG. Overprint problems, it's a very important part in case of when you are using overprints. We will be seeing later on when we discuss. I intend to make a separate lecture, a detailed lecture on analysis of the each and every patch that is present in the 5 page again output suite specification, or that output suite document. Okay, so it's quite interesting to analyze what kind of problems, overprint problems, that might occur, right? Annotations, it will be checked both by PDFX as well as GWG. Missing bleeds, this will not be checked by both PDFX as well as GWG, because whether bleed is present or not, that I don't think that is really the possibility for checking through pre-flighting. It is your choice, you might intentionally not provide any bleed. Okay, so that is, there is no meaning in checking the whether bleed is present or not. Okay, so this is the comparison between what are the errors, and what are, whether these errors will be picked up by during pre-flighting using simple, a normal PDFX standard without any added specification on top of it, and compared to with your GWG pre-flighting using GWG specification. So this is the kind of comparison that I wanted to draw over here, right? Next, in this I think four slides left in this particular lecture. In this particular scenario, what I am going to essentially talk about is what is the, slowly and steadily now we are going to the workflow part of the discussion. But we will not continue our discussion, we will not start our discussion of getting out workflow, or getting out output using the GWG workflow. Will not go there, but we'll just I'll just create a brief understanding or brief discussion on this particular process. Okay, so what is or how is rather how is PDF processed, any PDF processed in today's workflow? So let us say you are having some RGB image, right? So in this case, when I am saying RGB image, consider this to be embedded image, right? So as soon as you have an RGB image, you can put this RGB image in a specific layout. Now this layout can be of different types, right? You may be creating a layout for coated offset press, or uncoated offset press newsprint for some rotation or engraving purposes, in case of your flex or gravure. So in any layout you can arrange them using layout software, and then imposing and all this, right? So finally the imposed and the trapped and the complete layout PDF, when it is ready, then you run this GWG. Either if you're working on the basis of the PDFX1A standard, then you are supposed to use GWG 1v4 specification, and this has been the de facto standard or de facto specification both for PDFX as a standard and GWG as a specification for quite some time now, right? And then you will be generating a PDF X1A compliant file, PDF file, with a certain output intent. So this output condition is of course CMYK, and then it will be rendered using your CPSID. Now see, here I'm talking about this document, although it is saying today, but more what I would like to say here is this is a presently this is a thing of the past. Okay, because you see here I want to stress on this point. I told you at the beginning, live transparency is not allowed in 1.3, PDF 1.3, and hence it was not allowed in PDF X1A standard. Why is that? You have to understand why it is that. See, earlier on, this is, although that is why I said that although it is written as today, but this is, I think, a thing of the past only. Okay, so because I mean, there are people who are still using this, but most of the rip engines and the renderers today, they don't use CPSI anymore. You have some basic idea about CPSI. CPSI means an interpreter, very normalizer. Okay, so CPSI is your configurable PostScript interpreter, right? In the earlier on, your renderers would convert or would render the PDF files, or render would actually not take in PDF files, it would take PostScript files. It were not capable, the rip engines, they were not capable of taking PDF files, native PDF files as their input. They could only take PS files, PostScript files. So the moment you convert your PDF into PostScript, automatically everything gets flattened. And rips of that time, now most of the nowadays, almost all rip work on the basis of, or has got app, that is Adobe PDF print engine as their standard rip engine. Now, earlier on, when CPSI was the de facto kind of interpreter or normalizer for rendering the files, then because that renderer being a PS driven renderer, the rip could not, or renderer could not take PDF as their input. That is why they could only take PS as their input file. And this is exactly the reason why in PDF 1.3 or PDF X1A or GWG 1v4 specifications, in all these things, live transparency is not allowed, because it will not be present in your PS files. I mean, whenever you are creating, or kind of you're going back from PDF to PS, everything will get flattened. You create a PDF file with some transparency, some drop shadow, or some overprint, or whatever you like to see, or some specific blending mode, multiply blending mode, or overprinting on something, and then you create a PS. You export it as a PS file from any layout software or anything. See what is happening. The first thing is, there will be a thing, one option. I mean, dialog box will open. It will say flattening transparency or flattening. So that means PS does not support, PS files does not support transparencies. Okay, and that is why they do not support OCGs also. So that is why everything needs to be flattened. And since your RIP was only capable of taking PS files as input, the PDFX standard also did not allow live transparencies to be added in your PDF. But fast forward to today's workflow, you'll see today we are working with RIP engines, which are, since as I told, that many of them are based on the APP platform, Adobe's APP platform. This enables, see, what is the advantage of working with APP based RIP engines in comparison to CPSI based RIP engines? Because it is the nature of APP based RIP engines is they are capable of taking PDF as their input. So the level of functionalities, or level of elements or objects, whatever you like to call them, that you can add or you can put in that PDF file which you are going to rip for printing, that has a lot more elements, lot more functionalities than your that can be allowed in your PS file. Naturally, because nowadays RIPs are taking PDF as the de facto input files, right? You can do all sorts of editing also in PDF, and then you send the edited and imposed and trapped PDF file to your RIP engine, and it will render it. This has happened only because they are now based on APPs, not CPSI based RIPs. So nowadays, today, I would say this is more of a today scenario than tomorrow scenario. So this document, I've taken this image from all these images from GWG's 2015 workflow document. So you'll find these documents. I have given the link also in the first page. So there, since this was in way back in 2015, I think that is why from that standpoint. So this remains the same RGB image. You put it in the layout, and you get you use a certain specification, in this case X4 specification, and use a GWG 2015 specification to create certain PDF files, which are PDF X4 files. I mean PDF X4 compliant PDF files. Okay, so you can either generate a CMYK file with the input condition, or you can generate an RGB, I mean, a PDF file having RGB elements, or a PDF file having CMYK elements with an output intent condition given within the PDF file. Okay, and then the question is over here that you whenever you send either of these files, and the question is how can you place RGB files over here. I'll talk about this creation of media neutral files. You see, as soon as you are sending it to the RIP, any RGB element that is there will first get converted, color converted using the output intent condition that is provided in the PDFX file, right? So no matter if whether you have got RGB images or not, it will ultimately get converted. So no worries in that. But there is another reason. This is not the reason why RGB is used or RGB is allowed in your PDF files under PDFX standard or GWG specification. This is not the reason. The reason is we want media neutral files or media neutral elements within the image or within the PDF file as such. Okay, that is for a different reason. I will come to that in the next lecture perhaps. But this is how today's workflow work, or today's RIPS actually renders file. Why we have generated this PDFX4 files? Because today's RIPS are capable of taking in PDF files as their native PDF files as their input files or input file format. So this is exactly the reason. What is the advantage of working with PDFX4 specification or PDFX4 standard or GWG specification and generating PDFX4 compliant files along with it. Okay, the next type of standard or the workflow that I wanted to talk about. See, in this scenario, in this particular, before I move on to the future, what is the future of this particular workflow, PDF workflow, I want to focus on this point as well. See, in this scenario, normally vector artwork, you can use an RGB image, but when you are using a text or when you are using a vector artwork, you cannot use RGB as their color space in those elements, for those elements. So that is why you want to keep everything in RGB mode. Now the reason I am saying why it is important to keep everything in RGB mode, and that is preferred also nowadays, that I will come to later on. So if you don't understand why I am repeating this RGB, the functionality of RGB or use of RGB images and RGB based text or RGB based vector artwork, so don't get worried. I will come in a detailed explanation in the next part of the lecture, right? So that you cannot do. So even if you wish to create a RGB based PDF, uh, if you have got, if it's a simple picture, an image, then it's fine, everything is in RGB. But if it has got a text, most likely it will have, if it has got some vector artwork, so those components will be in CMYK device CMYK space, and the rest will be in the RGB space. Be it your ICC based RGB or device RGB, whatever. But there's a combination of CMYK and RGB you can see. If you really wanted to make a PDF exclusively with all elements, everything, text, vector, image, everything, with some RGB, ICC based RGB or device RGB color spaces embedded, you can't do that now. But in the future, we are moving towards the future with the advent of PDF 2.2 and PDF X question mark. We don't know in which PDFX standard this will be addressed, but it will be possible in the future to work with completely media neutral, to generate completely media neutral files, where all the elements, be it your text, be it your vector, images are already RGB. So everything it will be possible, or the standard will allow for those text, those vector artworks also to have an embedded ICC based or even a device RGB color spaces, unlike what is the scenario now. So in that situation, you will be able to create a PDF file which is exclusively having RGB elements to it. Ultimately, completely media neutral file or media neutral workflow with certain output condition. It can be for RGB output condition or CMYK output condition, and ultimately you will be able to render the file. So rendering is not really a problem, but creation or allowing this complete media neutral elements or exclusive media neutral elements within the PDF file, that is a challenge now. Let us see. This will be the next challenge that is taken up by the people delivering or creating these standards. So once this is ready, this is the future. Now you may naturally ask, so why you are focusing on this media neutral output so much? So as I already told you, I'll come to that in the next lecture. But today, now let us end this particular class or this particular lecture with the idea that now till now we have seen that there are various Gantt workgroup specifications, right? Now the question is, why is it why is it that or how is it, not why is it, but how is it we determine which specification we need to use? So this workflow is giving you a very good idea about what it is, right? So we start from whether you being a creator. So let's say you are a creator, you are creating that original file with the intent to print it, right? So now if you are a creator, then you come to this loop, I mean to this particular workflow. Now in this case, once you are creator and you you know what your output partner is, right? If you know it, then what do? You simply go to the next point, that is my output partner wants or can only handle flattened transparency. If this is the case, if you know your output partner means your printer. If you know your output partner and if you know that he can only handle flattened transparency, simple. You use GWG1 V4, which is based out of PDFX 1A of 2003 standard. You use that, right? All the transparency needs to be flattened. Now, here, if you don't know your output partner, right, in that situation, you still use GWG1V4 that allows CMYK spot colors and with your transparencies flattened. So why I told that, or this workflow specifies that you can or you should use 1v4, because see, you don't know once you don't know your output partner, it is safe to use a specification which is limited in its what can be allowed and what cannot be allowed. I mean, PDFX 1A is limited in that sense. It does not allow any end separations, it does not allow live transparencies, and a lot of other such limitations are there. So it is better, if you don't know, you use a specification where you will be sure that this is the minimum that your printer can deliver. This is something which your printer must deliver. That is why it is written as 1v4, right? And then we have, naturally, in this context, when you so these two ideas are clear, that if you know your partner, you move to the next one, and if you don't know your partner, you will use the PDFX or the GWG specification, which is providing you the minimum thing that you know that any printer should be able to print at least these things, right? Now, as I already told, if your output partner or your printer they can't handle transparency, live transparency, then you have to flatten them, and you have to use the GWG 1v4 that is based on PDFX 1A standard. If your partner can handle live transparency, right? So this cross means your partner can handle live transparency. In that case, after consulting with the output partner, I can deliver media neutral files, right? Now, if your partner can, work with live transparency, so naturally you won't use GWG1V4 specification. You can naturally automatically go to 2015 specification. Now the question is whether or not, now the question of live transparency is okay, right? So if your partner is able to use live transparency, you can use 2015 specification. But if your partner cannot handle live transparency, you have to use 1v4. Now this is that situation where your partner can handle live transparency, so you are using 2015. In both the cases, 2015. So what is the difference between these two? Now, here the condition is that if your partner can work with media neutral files, that means RGB files or RGB elements within your file, basically. If you know that your partner can work with this, then you need to work with this specification. I will show you all the specifications, so don't get worried that what are all the specifications, what is allowed and what is not allowed. So I will show you each and every specification. I will show the application settings from where you can download the presets for different native design applications where you can use this, or you can export the files, and you can go for pre-flighting these files. So here, as you can see, that you can basically if you know that your output partner can work with media neutral files, then you have to use GWG 2015 CMYK plus RGB. This is a specification. This is a specification which allows the use of both CMYK as well as RGB elements in your file. But if your partner cannot handle yes, so this RGB elements within your artwork or within your file, then you have to use GWG 2015 CMYK profile only, or specification only during exporting that file. Okay. Now this part of the workflow is clear. Now, if you are not a creator, if you're not a creator means you are working, this domain is for those who are working with native design applications. This is for more of non-design applications, maybe office applications or something like that. So here also, so this line, this cross means you are not a creator, this right means you are a creator. So that is the difference. So here also, if you know that you can handle only flattened transparencies, then you have to use 1v4 like others. Now, if you can handle live transparency, then you have to come to this condition where it says that you have to think about this, that whether you can work with media neutral files or not. If you cannot work with media neutral files, then only use 2015 CMYK specification for exporting your files. And if you can handle media neutral files, then you have to use 2015 CMYK plus RGB specifications for exporting the file, right? So hopefully now you get an idea that which specification you need to use. So it all depends upon you, in what sense, that what type of application you are using to generate the PDF, whether you are using a design application, native design application, or whether you are using a office application, right? Secondly, it also depends upon your output partner, that is your printer. So whether your printer is having the workflow, or whether your printer's workflow allows live transparency or not, whether your printer's workflow allows for use of media neutral files or media neutral elements in your file or not. So all these parameters, all these conditions you need to know while exporting your PDFs from your native applications. Okay, so depending upon what is allowed and what is not allowed in your printer's workflow, and what type of software you are using for generating the PDF, both of these factors come into play when deciding which specification to export, or which preset to export your PDFs to from your native design or native non-design applications, whichever you are using. And in the upcoming, I think, third part, I'll be showing you some demonstration about how to make these decisions, when to make these decisions, so, and how you can export to the correct specification, how you can your printer can perform that pre-flight checking, whether your file is meeting those criteria as referred in the specific PDF standard, or even the GWG specification, whichever you have profiled your you know your whichever you have used as the preset for getting the PDF as your output. So all these things demonstration I will be showing you. So hopefully this much is clear. In the next lecture we'll be talking more about some detailed workflow on how to get these files created, these PDFs created using you know native applications, native design applications and office applications, and using certain specifications from GWG to create the correct file, right? So all that workflow based discussions and application settings that are given by GWG, where you can download the presets for creating those PDFs using native applications, design applications, these things, what is media neutral workflow that I talked about, all these discussions I'll be doing in the next lecture. Perhaps some demonstration also I will start from the next lecture itself. If not, then the third part I will reserve for the demonstration. So hopefully whatever we have discussed here today was clear enough to you. Thank you for listening.